students. In this lecture, I am going to solve some more problems on non-homogeneous linear equations, students. Come on, write down. Solve dou square z by dou x square minus dou square z by dou y square minus 3 dou z by dou x plus 3 dou z by dou y, that is equal to xy plus e power x plus 2y, x plus 2y. Now this problem is very important, students, for giant k point of view. Solution. You write the symbolic form, students. First of all, symbolic form. What is symbolic form, students? D square minus d dash square minus 3d plus 3d dash into z, that is equal to xy plus e power x plus 2y. Now what is complete solution, students? Complete solution, complementary function plus particular integral. Complementary function. Now you write this as the factor form here, d minus md dash minus c, students. D minus md dash minus c. So this d square minus d dash square can be written as, it is like a square minus b square, students. So it can be written as d plus d dash into d minus d dash. Now from these two terms you can take in common, students, minus 3. So d minus d dash into z, that is equal to xy plus e power x plus 2y. Now here you can take in common d minus d dash into, here you get a d plus d dash minus 3 into z, that is equal to xy plus e power x plus 2y. Now by comparing this, students, what is m1, students? M1, that is equal to, m1 is 1. What is c1, students? c1 value is 0 because there is no constant, so value is 0. And m2, students, m2 here. In the formula we have minus m, students, but here we have plus 1. So you can write it as minus of minus 1, students. So m2 value is minus 1. c2 value, students, c2 value is 3. Therefore, what is complementary function, students? Complementary function, e power 0x, students, we get 1. So f1 of y plus m1 value is 1, students. So x plus e power c2x, students. So e power 3x. f2 of y plus x, students, but here minus 1 here. So m2 x, students. So minus 1 into x. This is the complementary function. Now particular integral, students. Now this particular integral I want to write here, students. Particular integral. There are two terms, students, xy and e power x plus 2y. So that I want to write here particular integral 1 plus particular integral 2. First I want to find particular integral 2, students. What is particular integral 2, students? I can write here 1 by d square minus d dash square minus 3d plus 3d dash into e power x plus 2y, students. E power x plus 2y, that is equal to 1 by d plus d square by, students, 1. So 1 square minus d dash square by 2 square minus 3 into d is 1 plus 3d dash means 2 into e power x plus 2y, that is equal to 1 by, come on, tell me, students, 6 minus 3, 6 minus 5, we get here 1. So we get finally 2 students. 1 plus 1 2. So e power x plus 2y. E power x plus 2y. I want to write the complementary function here, students. What is complementary function? f1 of y plus x plus e power 3x f2 of y minus x. And what is partial integral 2, students? Partial integral 2 is 1 by 2 e power x plus 2y. X plus 2y. Now let us find partial integral 1, student. Write down, students, partial integral 1. Particular integral 1. Now what is factor form, students, here? Factor form d minus d dash into d plus d dash minus 3, students. D dash minus 3 into xy that is equal to what is our formula, students? What is formula? 1 plus x whole power minus 1 minus x plus x square minus x cube plus some so on, students, or 1 minus x whole power minus 1 plus x square plus and so on. These are the formula, students. It is like 1 plus x or 1 minus x. Now I want to take this, students. I want to take this. So 1 by d minus d dash into, taking common, students, here for getting the form 1 plus x or 1 minus x, minus 3. So 1 by minus 3. Then we get, students, 1 minus of d plus d dash. I want to take in the whole power minus 1, students, like 1 minus of d plus d dash whole by 3 whole power minus 1 into xy. Once again, students, I want taking down minus 3 for getting the form 1 plus x. So we get here minus, taking down minus 3, so get 1 here, and minus d plus d dash by, we are taking down 3, students, so get 3 here. I am taking the numerator, students, so minus 1 will be x. Now it is like, students, 1 minus x whole power minus 1. So that is equal to 1 by minus 3 into d minus d dash into expansion, students. 1 plus x plus we have here d plus d dash by 3. So d plus d dash by 3 plus d plus d dash by 3 whole square plus and so on into xy, because we have only xy, students. If I am writing here d plus d dash by 3 whole cube, all the values are 0. So that is equal to minus 1 by 3 d minus d dash multiply, students, xy into 1, so xy plus 1 by 3 into 6, students, here derivative of x, so 1, we get here y plus d dash, students, derivative of y value is 1, so we get here x plus here expansion, students, d plus d dash whole square. What is expansion of d square plus 2d dash plus d dash square, students, d dash square. So we have here d square x here, so d square 2 times derivative, so the value is 0. D dash square means here we have only y, so the value is 0. So finally we get here 2 by 3 square means 9 into d means derivative with respect to x, students, so we get 1 into y. D dash means derivative of y, students, with respect to y, so we get 1. So close, students. So that is equal to again I want taking common here, because all the terms xy, yx like this, students, we can take in common either d or d dash. So I want taking common d, students, here. Again we get here 1 by minus 1 by 3 into d. I want taking the numerator, students, so 1 minus d dash by d whole power minus 1 into, come on, tell me, students, here xy plus 1 by 3 y plus 1 by 3 x plus 2 by 9, students, 2 by 9. That is equal to minus 1 by 3 d expansion, students, 1 plus 1 minus x whole power minus 1, like again, so 1 plus d dash by d plus, enough students. If I write d dash square, what happens? D dash square means all terms values are 0, so there is no need. So xy plus 1 by 3y plus x by 3 plus 2 by 9 plus 2 by 9. So that is equal to minus 1 by 3d. Multiply students. 1 into this one. So we get a 1. xy plus y by 3 plus x by 3 plus 2 by 9 plus 1 by d into derivative students. Derivative with respect to y students. Derivative with respect to y. So we get here derivative with respect to y is 1. So we get here x plus derivative y 1. So 1 by 3. Derivative of x is with respect to y students, the value is 0. So constant, the value also 0. So that is close. That is equal to minus 1 by 3 xy plus y by 3 plus x by 3 plus 2 by 9 plus 1 by d means integration students. Integral of x plus 1 by 3 dx. That is equal to minus 1 by 3 xy plus y by 3 plus x by 3 plus 2 by 9 What are students here? Plus x square by 2 plus 1 by 3x 1 by 3x. We have d students, d. See students here, x by 3, 2 by 3 x students. So that is equal to minus 1 by 3. 1 by d means integration xy plus y by 3 plus x by 3 students. You get here 2 by 3 x plus x square by 2 plus 2 by 9 into dx. That is equal to minus 1 by 3 integrating with respect to x students. So you get here we have x, so x square by 2, so x square y by 2 plus, see students have y by 3 with respect to x, y is constant students, so xy by 3 plus 2 by 3 integral of x dx students, x square by 2 plus integral of x square students, x square by 2, so x cube by 3, so into 2, get here 6 plus 2 by 9 into x students, 2 by 9 into x. This is the required particular integral students. Therefore, complete solution, that is equal to z is equal to, what is complementary function students? f1 of y plus x plus e power 3x, f2 of y minus x plus particular 2 students. Of course, you can write any way students. X plus 2 by 1 students minus 1 by 3 x square y by 2 plus xy by 3 plus 2 by 3. 2 into 3 6. 2 by 6 means 1 by 3 students. 1 by 3 x square plus x cube by 6 plus 2x by 9, which is the required solution of given problem students. Please remember students, this problem is very important in the external examination, in non-homogeneous equation especially. Hope you understand students. Jai Hind.